Welcome back, everyone. So in this next one, we're going to get into the actual meat of what this week is all about, and that is forecasting our priorities. I think it'd be advisable, if you haven't already, to look at the assistance document, and it's the tab, the forecasting PC 8833 and the 8833 STF, which is slip trip fall. This is, again, examples, but you can see here we're going to be taking, in our case, the accident department, and we're going to forecast that, and then we're going to look at just one particular, the number one prioritized cause, and see what we get. After that, we'll have another video in which we're going to kind of change course here, because I'm going to demonstrate that there's just too many accident departments. They're too parsed out. There's not enough information to focus on any one and get value out of it. So we're going to default to just looking at the accident source description. So these two tables here you see on the screen are the two that we're working toward. This is the step before the final step, which is to create a final results table. So we create these, individual forecasted loss for our priorities, and then we fill in this final table. That's really what we're working toward. So I like the one on the left here. I think that's a cleaner way to present, what our estimates are from an annual perspective and from a graphed forecasted perspective. This is our return on investment calculation. This is our information about our outliers, and this is other key information about our data set, the scaled down. Over here, I've got another example. I have the colors here. You can see where everything comes from. As I scroll down, you can see that this is how we're going to be forecasting losses into the future. This is from a few years ago, so you can see that's why it's 2020. And then down here, we've got the average. But ours is going to be a little bit different. We'll be able to look at a 5-year and a 2-year average. And when we parse it down, basically, I'll show you what we're going to do. It's actually very simple. We delete what we're not focusing on, and then everything self-populates. And we update these things. If we create this table properly, we only have to create it once, and it kind of does the work for us. So that's what we're going to be doing. So let's take a look at our data where we left off. So where do we leave off? I had created this additional table to kind of investigate the outliers. I built it adjacent to the fiscal year analysis on purpose. And remember, I had done the 2-year, so the 2010, 2011 versus the 5-year average. By building this here, it's going to always be there, so I don't have to do it again. But what's interesting is when we have too many open claims, that means that the total paid that we're graphing is actually it's going to increase. And so if we look at 2021, 25% of the claims from 2021 are still open, with a potential of it increasing by almost $250,000. That's important. We look at 2020, only 4%, or 3.57% are open, only 33%, 5 there. So these aren't going to go up much more. It has the potential to go up considerably. And 2017, 2018, almost nothing, a blip, not much. 2020, we only have, 3 claims total. They're all open, and so we have to complete that year. So we can still use 2021. The number of claims won't change because that's set, but the total paid amount is going to change because we still have, again, 14 open claims at 25%. And we still have, I think, how many open claims down below? We have 5 open claims down below. And that will increase as well, and we should pay attention to that later on. So what do we do now? Well, we're going to copy and paste the work we did here to a new tab. Paste. So the outliers are removed, and this is sorted by fiscal year. And we're going to scroll down here. And what we want to do is we're going to focus on the accident department. And I'm going to show you, we're going to do a couple of these in this video, and then we're going to default to something else. So the number one priority, both before and after the outliers being removed, was mix. So we're just going to focus on mix. So I'm going to put down here, mix forecasts. That's what I'm going to call it. You can call it what you want. Mix forecast. Or we could call it priority number 1 by accident department. So accident department priority 1. Or we can call it priority mix. Call it what you want. That's what it is. So here's what we're going to do. You see everything here is populated. Everything here equals out. Here's what we're going to do. We're going to go up to the top. Well, not to the top, but to the new header row. I'm going to turn that into a filter. I'm going to filter by accident department because that's what I'm interested in. And I'm going to delete. I'm going to go over here to the left. I suppose I have to blow it up for you a little bit. I'm going to go over here to the left. I have to be able to see accident department, and I'm going to highlight and delete every claim that is not mix. So I'm going to scroll down until I find mix. Oh, there it is. So ends with maintenance. I'm going to delete it. Delete. Gone. It's gone from existence on this page. Go down to the bottom of mix and delete everything else that is not mix. So that all I have in my data set for this tab is claims that occurred in the accident department labeled mix. Do I know what that is? I do not. Our descriptives have updated. We should see probably how many we have here. Well, actually, I can scroll down here and see. So mix, which is the only one, see, is 27. We have 27 mix. I may as well go ahead and throw that in there. We have a total of $60,000. The average is this amount. The median is this amount. The maximum is 17%. As far as the fiscal years, there were 6 here. Well, that brings us down to 21 from 17 to 21. And as you can see, it jumped up in 18 and then it comes back down. So it's not going to be a pretty graph by any means. Each year there's an average of 4, and we can see we were close to that, in the final 3 years. The average paid is about $9,000 per year. The average per claim is about $2,200. And how different is that from before? It's about the same. Didn't change. I want to point out something here that this is no longer good. Why? Because these ranges have been destroyed. This is no longer representative. And I'm not even going to play with it. There is one open claim. There's one open claim. Is that it right there? And let's see what year it's in. It's in 2021. Okay, so 2021 cost could go up by another 13.8. That's all we know. But again, this is no longer a valid. It's no longer valid. Okay, it was built on what was before. That's why I always told you we do different. When we're going to do a different calculation or a different analysis, we go to a different tab. That was no longer valid because it was based on the sort at the time. Everything else is overall. So as we look here, we see that overexertions are number 1. We'll get to that. That'll be our next step. Over here, boy, kind of spreads out. Our number 1 is probably the 49, which is strain injury. That's why we created the new cause code of the parent code, so that we could catch more things. And it was number 1 before and after. So it's our number 1. We also need to go down below and delete all of the overexertion claims that did not occur at mix. So here's a mix. And I can do this manually. I'm just going to kind of look at it. I should sort it if there was a lot. I'm only seeing 1. There's only 1 overexertion from mix. Delete. It was a slip, trip, and fall. I know that. It is the most expensive claim. It was a slip, trip, and fall. Yeah. So this was the most expensive claim. So before and after, it's still number 1. Sorry, my nose is running a little bit. I apologize. It's probably kind of gross. So what we want to do now is we want to recreate that table. I'm going to copy and paste it. It may not work. I may have to do some interesting updates to it. It's on the forecasting PC 8833. I'm going to copy this. We'll see if it works. It may not. I'm going to have to obviously delete all that other stuff, but because it's built within that particular thing there. Let's see. Where do I want to put this? I want to be able to see these things, but I don't want to get too crazy. I can shrink that down. I think it's 3 over. So let's put it right here. Let's see what happens. No, not bad. That's a decent place for it. Because I'll put the figures here. All right, so I need to clean this up, obviously. What size are these? They're 10. That's fine. And I got to clear all this. Oh, I don't want to clear that. Clear, and clear. And I'm going to forecast out to 2022. No, I'm not, because it's on here. I'm going to forecast out to 2023. Yeah. 2022 already started. These should all be typed out better. Obviously, they're all abbreviated. But let's populate this, and then I'll show you what happens when we then reduce it down. All right, so let's first, if we look at the table, the averages have already been calculated for us. So what we can do is, for the table, the average number of claims per year, average number or occurrence of claims per year. So I go equal sign, and then I click on the average, which is 4. 4 claims per year. The average cost per claim, I click an equal sign. I go over here. The average is this amount. And then the forecasted loss, this is just going to simply be the annual average, which is this right here. Okay, so that's already been taken care of now. And now that I've set it up this way, it will automatically update for everything I do in the future. We have to actually find that stuff. So number of outliers, there's 1. We looked at it. The average doesn't really matter. The total, I'm going to hit an equal sign and scroll down. Later on, I'll show you how to do that, make that easier on us. But for right now, is it open? That's a question. I can actually look up here. It is not, I believe. Is it open or is it closed? Where did it go? What the heck's going on here? Oh, geez, I really went past it, didn't I? It's closed. Okay. So there are 0 open outliers. See, I did it manually. Don't like to do that. Percent of outliers total paid. That is basically equal to that divided by, I believe, the original amounts. The original 22. Yep, 12%. All right. Number of open claims. So I think I got to do a number of open claims. Total number of open claims is equal to, I just have to go up to this table here. There's 1. You see it right there. $0 claims. This used to be a big deal. It's not a big deal now. Countable $0 claims. There are 0 of them. And the median is this right here. So by clicking on a cell, as long as the orientation stays the same, these will automatically update. These I'll have to do manually. These I'll have to do manually from now on. Let's see. Number of open claims. I'm going to... Actually... I'm going to, because I started looking at the total incurred, I wonder if I could do the difference between the two. But no, let's not do that now. If it was a bigger data set, I would have. So they've paid this much, so it could go up by another 4,000. Is that right? Yeah, 4,000. So there's a $4,000 increase potential for the year in which that is realized. All right, let's do the graphing. So we're going to do fiscal year and number of claims. So first I have to do the y-axis. So I'll go 17 through 21, insert scatter plot. So we're trying to forecast the claims. I can do another one real quick, in which I'll do the total paid, and it's 17 through 21. Insert here. And then the last one is the average. We didn't really do the average before. I didn't see value in it. We may not find any value in it now either. Insert scatter plot. But we're still going to do it. All right. So I already got my annual averages. Now we're going to do actual forecasting. So for this first one here, this is the count. My dog just barked. I don't know what his deal is. Edit. So the name is number of claims. The X values are the fiscal years. Hit OK. For this one now, I got to fix the axis, so format axis. I'm going to change the major from a 0.5 to a 1. I'm going to put in a trend line. And I'm going to go forward by 2 years. That's what I was doing before. So I'm going to put in an R² value. Yeah, there we go. So that's the estimate. It's going down because 2018 is like that. All right, let's update this one. I'm going to select data, edit the series. The name is total paid. The X values are the 17 through 21. Hit OK. I'm going to fix the axis. Change that into a 1. Sorry about the snort. Or please excuse the snort. I'm going to add a trend line. I'm going to forecast forward 2 years. I'm going to give the y² or the r², excuse me. Close it. And then I'll do the average as well. Select data. Edit it. The name is average per claim. The X values are the 17 through 21, and that's that. Fix the axis. I wonder, there's probably a way to set this up as a default, so I don't have to do it each time, but yeah. Trend line, forecast 2 years, and give me the R². All right. Let's fill in our table now, the part where we have to do it manually. And this is sometimes sort of an eyeball of what we need to get. Yeah, all right, so let's look. So for the average number of claims per year, we just kind of look, so it's up to 2023, and then we try to just go over. You can't do partial, so I'm gonna say it's 2. Figure says it's gonna be 2 per year. The average is going up because of that, so this is not a great representation. What's the R²? 0.49, not great. This is even worse. 0.13. So we will probably have to default to the annual averages here. In 2023, it looks like the average is right around 9,000. That's too high, of course. And the forecasted loss is right here. And so in 2023, it's going to be between, should we go 26,000? It's above 25. It's in between. I'm just going to go 26. So we have a range here. Excuse me. So the estimated loss is going to be the more conservative of the two. So the estimated loss is going to be, and I'm going to round it. I'm just going to say, 9,300. I mean, I could keep that in there, but it's $3 and it's easier to work with bigger numbers. The desired return on investment is 25%. That's what we're going to use. And the way we calculate it, and this is going to be discussed in a different video, is equal to, and it's basically the estimated loss divided by 1 plus the ROI. And I'll show you how we were able to get that. And so this would be our requested investment for just the mix. Again, this is just the first step. The next step is going to be reducing it down even further. And I think what I'd like to do is I'm going to kind of let you marinate on this. We did a lot here. We'll be replicating this technique again and again. We'll just be reducing what's up here. No, I'm just going to do it. I'm just going to do it because you're here. You're happy. Probably not. Now what we're going to do is we're going to sort it, and we're going to look at the overexertion. So I'm going to turn this into a filter. I'm going to filter by new cause. And I'm going to delete everything that is not overexertion. Delete. Why is this struck by against yellow? I thought it was supposed to be something different. Whatever. So there's my overexertion. This has all been updated, but I have to redo my figures. These figures are still based on the previous page. I should probably name this accident. No, this is mix and overexertion. Just go mix OE. Go down below, and this goes to 0 because that was a slip, trip, fall. It was not an overexertion, so I have to get rid of it. So let's redo these based on what we have here. And all we really need to do, so this is delete, delete, delete. So there are zeros there. Open claims are 0, that's 0, median is still there. All right, so here's what we need to do. I'm gonna hit here and go select data. And when I do that, if you look down below, you see it highlights the previous tab, right? So I'm gonna go edit. All I need to do is change the Y values. So what I'm gonna do is I'm gonna click on my new tab, see the mix OE, and I'm going to click on 17, 18, 19, 20, 21. Hit the little window, hit OK. So that's been updated now based on what we have here. Ugh, that's really ugly, isn't it? Let's do it with total paid. Select data, edit. Just going to do the Y values. X's are still the same, but I have to click on my tab and then do the 17 through 21. And hit OK. Look at that. Interesting. And the average paid, we can do that too. Click on it, go to select data, edit it, go just to the Y values, click on my tab, or click on the tab I'm working from, and yeah, we already have an error. This isn't going to work because we had a division by 0, and that's how you get that weird thing, that entry there. All right, let's manually enter these. They've now been updated. So, number of claims, 1. Can't, because I'm not going to round up. The average cost per claim is, jeez, so unrealistic. Let's go 16,000. From the figure in 2023, it's going to be about 17,000. I don't know. It kind of looks like it. I'm just going to go 16 because that's what it was before. Oh, no, the total is 16. Let's go total 17 then. Because that was 16. Yeah. Kind of works out. Again, what's the... That's the lowest of the two, and we get that. That is what we're trying to do. We're attempting to figure out this number here based on this other data. So we'll be reporting these other elements, but this is, I mean, look at these R square values. They're kind of ridiculous. They even look ridiculous. I don't trust them. So really we're going by an annual average. It's a nice low number. It is what it is. So we're going to be shifting gears now in the next video, and we're going to look just at, maybe I'll do one more of these as an example. Maybe I'll try to do SAN. Was that our other high one? I'll go back to this one here. This is what I originally copied and pasted. SAN at 18. It's just going to get worse. To show you. Maybe this was enough. We'll switch right away. This is evidence that it's not a great way to go. There's just the accident department variable is just not good. Not good at all. And if we were to go by policy class code, we would just be looking at the accident source description anyway. But typically what we get to do is we get to use policy class code. I mean, it's a better representation. We have priorities, and then we use the new cause code in order to capture things like we just did. But since we don't have that, in the next one we're going to go into the accident department.